project size classification relies on factors such as budget, scope, and complexity, which can vary across industries. A small project is generally under $200,000, involving limited scope and complexity. Examples include residential renovations, small commercial fit-outs, and equipment upgrades. A medium project ranges from $200,000 to $1 million, encompassing a broader scope and moderate complexity. Examples include office renovations, small-scale commercial construction, and technology implementations. A large project exceeds $1 million, involving significant scope, complexity, and stakeholder involvement. Examples include infrastructure projects, large-scale commercial developments, and complex technology overhauls. For context, the specific examples mentioned that cost $400,000 to $550,000 would generally be considered medium-sized projects due to their budget. In summary, small projects are typically under $200,000. Medium projects range from $200,000 to $1 million. Large projects exceed $1 million. It is important to note that these classifications can vary depending on the industry and the specific project requirements. The scale of electrical work in the mentioned store, for example, involves the installation and maintenance of electrical systems to power lighting, refrigeration, and other essential functions within a large retail space. This includes the installation of electrical panels, wiring, and lighting fixtures, as well as ongoing maintenance and repairs to ensure the safe and efficient operation of the electrical systems. Firstly, the design phase involves assessing the electrical needs of the store, including the layout of the building, the types of equipment that will be used, and the local electrical codes and regulations. This phase may also involve creating detailed electrical schematics and plans. Secondly, the installation phase involves installing the electrical panels, wiring, lighting fixtures, and other electrical components according to the design plans. This phase may also involve coordinating with other contractors, such as plumbers and HVAC technicians, to ensure that all of the building systems are properly integrated. Thirdly, the testing and commissioning phase involves testing the electrical systems to ensure that they are functioning properly and that they meet all applicable codes and regulations. This phase may also involve training the store staff on how to operate and maintain the electrical systems. Fourthly, the maintenance phase involves performing regular maintenance and repairs on the electrical systems to ensure that they continue to operate safely and efficiently. This phase may also involve responding to emergency repairs, such as power outages or electrical fires. Specific electrical considerations for large retail spaces include the following. 1. Lighting. Large retail spaces require a significant amount of lighting to create a bright and inviting atmosphere for customers. This lighting must be energy efficient and must be designed to minimize glare and shadows. 2. Power distribution. Large retail spaces require a complex power distribution system to provide electricity to all of the different areas of the store. This system must be designed to handle the large electrical loads that are associated with retail operations. 3. Emergency power. Large retail spaces must have an emergency power system in place to provide electricity in the event of a power outage. This system must be able to power essential systems such as lighting, security systems, and fire alarms. 4. Electrical safety. Large retail spaces must be designed and operated to ensure electrical safety. This includes installing ground fault circuit interrupters, GFCIs, in wet areas, and regularly inspecting electrical systems for damage. The National Electrical Code, or NEC, provides detailed requirements for electrical installations in commercial buildings, including retail spaces. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. Some specific NEC requirements that are relevant to electrical work in the mentioned stores include Article 210.12, which requires arc fault circuit interrupter, or RFSI, protection for branch circuits that supply dwelling unit. Article 220 provides requirements for calculating the load on electrical systems. Article 230 provides requirements for service entrances. Article 250 provides requirements for grounding and bonding. Article 300 provides requirements for wiring methods. Article 310.15 provides requirements for conductor ampacity. Article 400 provides requirements for flexible cords and cables. Article 410 provides requirements for lighting fixtures. Article 430 provides requirements for motors and motor circuits. Article 440 provides requirements for air conditioning and refrigeration equipment. Article 500 provides requirements for hazardous locations. Article 517 provides requirements for healthcare facilities. Article 518 provides requirements for places of assembly. Article 520 provides requirements for theaters, motion picture studios, and similar locations. Article 547 provides requirements for agricultural buildings. Article 550 provides requirements for mobile homes and for recreational vehicles. Article 600 provides requirements for electric signs and outline lighting. Article 620 provides requirements for elevators, dumbwaiters, escalators, moving walks, wheelchair lifts, and stairway chair lifts. Article 625 provides requirements for electric vehicle charging systems. Article 640 provides requirements for audio signal processing, amplification, and reproduction equipment. Article 645 provides requirements for information technology equipment. Article 668 provides requirements for electrolytic cells. Article 670 provides requirements for industrial machinery. Article 680 provides requirements for swimming pools, fountains, and similar installations. Article 690 provides requirements for solar photovoltaic systems. Article 694 provides requirements for small wind electric systems. Article 695 provides requirements for fire pumps. Article 700 provides requirements for emergency systems. Article 701 provides requirements for legally required standby systems. Article 702 provides requirements for optional standby systems. Article 705 provides requirements for interconnected electric power production sources. Article 725 provides requirements for Class 1, Class 2, and Class 3 remote control signaling and power limited circuits. Article 760 provides requirements for fire alarm systems. Article 770 provides requirements for optical fiber cables and raceways. Article 800 provides requirements for communications circuits. Article 810 provides requirements for radio and television equipment. Article 820 provides requirements for community and television (CATV) and satellite radio and television receiving systems. Article 830 provides requirements for network-powered broadband communications systems. Article 840 provides requirements for premises-powered broadband communications systems. These are just a few of the many NEC requirements that are relevant to electrical work in retail spaces. It is important to consult the NEC and other applicable codes and regulations to ensure that all electrical work is performed safely and in compliance with all applicable requirements. Additional considerations include energy efficiency, load calculations, safety, and future expansion when planning and executing electrical projects in large retail stores. Energy efficiency is crucial in large retail spaces due to the significant energy consumption required for lighting, HVAC, refrigeration, and other operations. Implementing energy-efficient technologies and practices can lead to substantial cost savings and environmental benefits. Firstly, LED lighting offers significant energy savings compared to traditional lighting systems. They consume less power, have a longer lifespan, and produce less heat, reducing cooling loads. Secondly, high-efficiency HVAC systems can reduce energy consumption while maintaining comfortable temperatures throughout the store. Smart thermostats and built-in automation systems can optimize HVAC operations based on occupancy and weather conditions. Thirdly, refrigeration systems account for a significant portion of energy consumption in grocery stores and supermarkets. Implementing energy-efficient refrigeration equipment and practices, such as door gaskets, Anti-sweat heaters and proper maintenance can reduce energy waste. Load calculations are essential for determining the electrical capacity required to support the store's operations. Accurate load calculations ensure that the electrical system can handle the demand without overloading or causing safety hazards. Firstly, lighting load should be calculated based on the type and number of lighting fixtures used in the store. Factors such as lighting levels, control systems, and occupancy sensors should be considered. Secondly, HVAC loads should be calculated based on the size of the store, climate conditions, and occupancy levels. Factors such as insulation, window efficiency, and ventilation rates should be considered. Thirdly, receptacle loads should be calculated based on the number and type of appliances and equipment used in the store. Factors such as power consumption, usage patterns, and diversity factors should be considered. Fourthly, motor load should be calculated based on the horsepower and operating characteristics of motors used for refrigeration, HVAC, and other equipment. Factors such as starting currents, duty cycles, and efficiency should be considered. Electrical safety is paramount in large retail spaces to protect employees, customers, and property from electrical hazards. Implementing comprehensive safety measures and adhering to electrical codes and standards are essential. 1. Regular inspections and maintenance of electrical systems can identify and address potential hazards before they cause accidents. Qualified electricians should conduct inspections to check for damaged wiring, loose connections, and other issues. 2. Ground fault circuit interrupters, or GFCIs, should be installed in wet areas such as restrooms, kitchens, and outdoor locations to protect against electrical shock. GFCIs quickly detect ground faults and energize the circuit. 3. Surge protection devices, or SPDs, should be installed at the service entrance and throughout the electrical system to protect against voltage surges caused by lightning, power outages, and other events. SPD divert excess voltage to ground, preventing damage to electrical equipment. 4. Proper grounding and bonding of electrical equipment and systems can minimize the risk of electrical shock and fire. Grounding provides a low impedance path for fault currents to flow back to the source, tripping circuit breakers or fuses. Future expansion should be considered when designing the electrical system to accommodate potential growth or changes in the store's operations. Planning for future expansion can minimize the need for costly and disruptive electrical upgrades down the road. 1. Spare capacity should be included in electrical panels and distribution equipment to accommodate future loads. This can be achieved by installing larger panels and using higher capacity conductors. 2. Raceways and conduit systems should be designed to accommodate future wiring needs. This can be achieved by installing larger conduits and providing spare conduit runs. 3. Flexible wiring methods should be used to allow for easy modifications and additions to the electrical system. This can be achieved by using flexible metal conduit or cable trays. 4. Modular electrical equipment should be used to allow for easy expansion and reconfiguration of the electrical system. This can be achieved by using modular panels, switchboards, and motor control centers. By considering these factors, electrical projects in large retail stores can be planned and executed effectively, ensuring reliable, safe, and efficient electrical systems that support the store's operations. Furthermore, understanding the financial aspects, risk management, and project lifecycle are vital for successful project execution. When considering the financial aspects, budgeting and cost control are essential components of project management, ensuring that the project remains within its financial constraints. 1. Develop a comprehensive budget that includes all project-related costs, such as labor, materials, equipment, permits, and contingencies. Use historical data, industry benchmarks, and vendor quotes to estimate costs accurately. 2. Track project expenses regularly and compare them to the budget. Use project management software or spreadsheets to monitor costs and identify variances. 3. Implement cost control measures to minimize expenses without compromising quality or safety. Negotiate favorable pricing with suppliers, optimize resource utilization, and streamline project processes. When considering return on investment, or ROI, Evaluate the financial benefits of the project in relation to its costs to determine if it is a worthwhile investment. 1. Calculate the project's ROI by dividing the net profit by the total cost. Use discounted cash flow analysis to account for the time value of money. 2. Compare the project's ROI to the company's investment criteria and hurdle rates. Only proceed with projects that meet or exceed the required ROI. 3. Consider the intangible benefits of the project, such as improved efficiency, customer satisfaction, and employee morale. Quantify these benefits whenever possible to include them in the ROI calculation. When considering funding sources, identify and secure funding sources to cover the project's costs. 1. Explore various funding options, such as internal financing, bank loans, grants, and private investors. Evaluate the terms, conditions, and interest rates of each option. 2. Prepare a detailed business plan and financial projections to present to potential investors or lenders. Highlight the project's potential for profitability and growth. 3. Establish a line of credit or revolving loan to provide flexibility in managing project expenses. Ensure that the funding source aligns with the project's goals and objectives. When considering risk management, identifying, assessing, and mitigating project risks is crucial to minimizing potential disruptions and ensuring project success. 1. Conduct a risk assessment to identify potential risks that could impact the project, such as delays, cost overruns, safety hazards, and regulatory compliance issues. Use brainstorming, checklists, and expert opinions to identify risks. 2. Assess the likelihood and impact of each risk. Prioritize risks based on their potential severity. 3. Develop risk mitigation plans to address each identified risk. Use strategies such as avoidance, transfer, mitigation, and acceptance to manage risks effectively. When considering contingency planning, develop contingency plans to address unexpected events or emergencies that could disrupt the project. 1. Identify potential emergencies that could impact the project, such as natural disasters, equipment failures, and labor strikes. Develop contingency plans to address each emergency. 2. Establish communication protocols to ensure that all stakeholders are informed of the emergency and the contingency plan. Use backup communication systems to ensure that communication channels remain open. 3. Allocate resources to support the contingency plan. Ensure that the resources are readily available and that personnel are trained to use them effectively. When considering safety protocols, implement comprehensive safety protocols to protect workers, customers, and the public from harm. 1. Conduct regular safety inspections to identify and address potential hazards. Use checklists and safety audits to ensure that all safety protocols are followed. 2. Provide safety training to all workers to ensure that they are aware of potential hazards and how to mitigate them. Use hands-on training and demonstrations to reinforce safety concepts. 3. Enforce safety regulations and disciplinary procedures to ensure that all workers comply with safety protocols. Use progressive discipline to address safety violations. When considering project lifecycle, understanding the different phases of the project lifecycle is essential for effective project management and successful project delivery. 1. Initiation involves defining the project's objectives, scope, and deliverables. Conduct a feasibility study to determine if the project is viable. 2. Planning involves developing a detailed project plan that outlines the project's tasks, schedule, budget, and resources. Use project management software to create and manage the project plan. 3. Execution involves carrying out the project tasks according to the project plan. Monitor progress and address any issues that arise. 4. Monitoring and controlling involves tracking project progress and comparing it to the project plan. Use project management tools to monitor progress and identify variances. 5. Closure involves finalizing the project deliverables, obtaining client acceptance, and documenting lessons learned. Conduct a post-project review to identify areas for improvement. By considering these aspects, electrical projects can be managed effectively, ensuring successful project delivery within budget and on schedule.